Section 3.5, equations of parallel and perpendicular lines. Our essential question: how can you write the equation of a line that is parallel or perpendicular to a given line through a given point? First thing we want to define here is slope. The slope of a non-vertical line is the ratio of vertical change, often referred to as rise, to the horizontal change, often referred to as run, between 2 points. Okay, so a lot of you have heard rise over run as our slope. Okay, that's the ratio we're looking at there. So our equation, m, is normally the letter we use for slope. So y2 minus y1 over x2 minus x1 gives us our slope. So example 1 is asking us to find the slope of a line that passes through the 2 points. So we're just looking at those 2 points. What you define as your x1, y1, x2, y2 doesn't matter as long as you're consistent. Okay, so if we say this is x1, then this has to be y1, x2, and y2. If you flip it, it will stay the same as long as you're consistent in what you do. So based on what we did here, y2 would be 0, y1 is 3, x2 is negative 8, x1 is negative 4. So I have negative 3 over negative 12. The negatives cancel out. And then we can reduce 3 over 12. So our slope here is 1/4. If we look at B, right, we'll do x1, y1, x2, y2. So I'm going to do negative 2 minus 3. And 5 minus 6. So I get negative 5 over negative 1, which will reduce to 5 over 1. Okay. Depending on what you're doing with that, 5 over 1 you could write as 5. We can also leave it as 5 over 1. Either is acceptable. Sometimes it varies based on the situation. But 5 over 1 or 5 is our slope. So then our goal is to look at lines here. So we get our slope of parallel lines. Okay. In the coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. We keep saying non-vertical. Realize if we go back up to our slope formula, a vertical line, you're going to get a 0 in the bottom. You can't divide by 0. So the slope of vertical lines is undefined. So even though this says the 2 non-vertical lines are parallel if the slope's the same, if they're both undefined, that's also the same. They would also be parallel. Okay, so so here, right, the slope, right, of this M1, if it's equal to M2, right, those 2 lines are parallel. Okay. Slopes of perpendicular lines, we reference this at the end of 3.4. In a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. Okay. Horizontal and vertical lines are perpendicular, even though it doesn't work. And this can also be said as they are negative reciprocals, which for some people is easier to see. Okay, if I look at 2 over 3, the reciprocal of that is 3 over 2. The negative reciprocal has the sign changed. Okay, so if I multiply those together, I get negative 1. That always is true with negative reciprocals. So that may be an easier way to think of it. Okay, if I flip this over and change the sign, what is my value? And that's what I want for perpendicular lines. So then example 3, we have 3 different examples here. We have 2 on this side and 1 on the next. Okay, it asks to tell whether the lines through the given points are parallel, perpendicular, or neither. So they give us 2 different lines, so I need to find the slope of those and compare them. Okay. So here we'll do -1 minus -1 over 3 minus -5. This gets me 0 over 8. Line 2, we have 3 minus -8 and 4 minus 4. Gets me 11 over 0. Okay. This would be my horizontal line and my vertical line. Okay, so they are going to be perpendicular. All right, the numbers, the 11 and 8 don't match, but the zeros are the main number in those. Okay, so since 0 is on the top, that's 0. 0 is on the bottom, that's undefined. Those are basically negative reciprocals. Not officially, but they work as negative reciprocals for what we're doing. Then B, so line 1, I have 0 minus 4 over -3 minus -2. So that's getting me -9 over -1. Wait, no, -4. -4 over -1. If I look at my other one, I have 1 minus 5 and 3 minus 4, which also gets me -4 over -1. Now, if I'm actually looking at slope, I would want to reduce these. I would want to cancel out my negatives. And if they're not the same, I would definitely want to do that to see how they ended up. But in this case, these are the same, so I don't need to go further. I know these are parallel. Okay, but again, officially the slope here would be 4, and the slope there would be 4. And flipping over to our last example 3, we gave the instructions again here, but it's the same instructions. I'm looking to see if they're parallel, perpendicular, or neither. Okay, so we have 5 minus 2 and 6 minus 0, which gives us 3 over 6. And then I have 0 minus 4 and 4 minus 2, which gives me -4 over 2. Okay. Now, most people's initial reaction on these is neither, but again, remember to reduce. 3 over 6 reduces to 1/2. -4 over 2 reduces to -2 over 1. Okay, this is one place where it's an advantage to keep that 1 in the bottom. Here I have negative reciprocals. That means these lines are perpendicular. Then example 4 says write the equation of a line that passes through point P and is parallel to the line with the given equation. Okay, so first thing, I have this equation. It's not in a nice thing. First thing I want to do is get that in y equals mx plus b form. So divide by 2 in this case. Y equals 3x minus 4. Okay, so my slope of my original line, which I'm going to call M0, is 3. So when I'm writing the equation of the parallel line, I still want the slope to be 3. Right? We're going to write our equation y equals mx plus b. That y and the x will stay there. The m and the b are what I want. So when I'm writing this equation out, okay, I'm going to put my final answer here. Y equals 3x. What I need is my b. It's not going to be -4 because that's the line I already have. It's going to be the line that goes through 0, 5. Okay. So what I do with that is I plug in. This one's really easy, but in general what I do is I plug in. I have my y is 5, my slope is 3, my x is 0, and I'm looking for my b. And then I solve that for b. In this case, 3 times 0, it's nice and easy. B is 5. So that is my equation of my line. Y equals 3x plus 5. Okay. Then B, they give me y equals negative 2. Okay. Now, y equals negative 2, if we look at our xy plane, y equals negative 2, this is 0, 0. All right, so negative 2 would be down here. This would be the line, y equals negative 2. So the line parallel to that is also going to be vertical. So we're looking at what the y is equal to here. So that would just be y equals 8. That would be my parallel line. Okay, I don't need to worry about my slope because y equals negative 2 is my original equation. Okay, if it had x equals here, that would be a vertical line, so I would go with what the x is equal to. Okay. Now, example 5, same concept, but here we want perpendicular. So now we want the negative reciprocal of our slope. So if we look at our original line here, right, my slope is 2. So my slope of my perpendicular is going to be the negative reciprocal of that, or negative 1/2. So when I write the equation of the line, I'm going to have y equals negative 1/2 x, and then I'm going to have my b. So again, my answer is going to be over here. Okay. So same concept we used up top, but we don't have the nice 0 here. Also, when I plug in, I'm not going to use my old slope. I'm going to use my new slope. So I have my y is negative 1. My slope is negative 1/2. My x is 1. And I'm looking for b. Okay, so I have negative 1 equals negative 1/2. 1 times. If it helps, you can write that out as negative 0.5. Some people find that easier. So I'm going to add the 0.5 to both sides. And my b then is negative 0.5. All right, so I'm going to have here minus 0.5. And that is the equation of my line. B, they give me x equals 6. So similar to what we looked at up here, okay, we look at that as a graph. X equals 6 would be a line over this way, going like this. So the line parallel to that would be x equals negative 1, but I want the, which would be over here, but I want the line perpendicular to that through this point, right, which is about there. So then my line perpendicular to that will be y equals negative 3. Okay, so if you have your equation of a line y equals or x equals, parallel, you go with the same point. Perpendicular, you go with the opposite point. So x equals 6, so y equals negative 3. Okay. And that is the end of our notes on 3.5 and ends chapter 3.